Swayam Prabha. Digital India. Educated India.
Hello everyone, so I again welcome you to the course Nursing Research and Statistics, and in today's lecture we will be talking about tests of significance. I am Dr. Harmeet Kaur Kang from Chitkara University, Punjab. Let us see the learning outcomes of today's lecture. After this lecture, the students will be able to understand the concept of hypothesis testing, because we will be talking about the different statistical tests which we use to test the hypothesis, then differentiate between parametric and non-parametric tests, and then they will be also be able to understand the tests of significance of differences. Before moving forward, we should be knowing about different basic terms. The first one is sample versus population. Before talking about the statistical analysis, I think you should be very clear that what is the difference between sample and population, and why do we go for the statistical analysis. So as in the earlier lectures we have already talked about sample, that sample is a subset of the population, whereas population is the entire set of the subjects on whom you are going to do the research study. So it is always very difficult to do a study on the population, because for a researcher to reach each and every person of the population is very difficult. So always the researchers take a subset of the population, or they take a sample and they do a research study on the sample. But then our target population is always the entire set. Now, based upon the sample's finding, can we generalize our findings on the population? For that, we need the statistical analysis. So, statistical analysis tells us that whatever findings, quantitative findings we are getting from the sample, whether these will be significant when we will be talking about the population also. So that is why you should be able to understand that whatever statistical analysis we are doing on the sample is basically to find out the population parameters. Another important basic term is standard deviation versus standard error. When we talked about the different measures of variability, we talked about the standard deviation. So standard deviation was the average deviation of each and every value from the mean in a sample. Now when we are talking about the statistical analysis, we are not bothered about the samples findings, but we want to know whether these findings can be applied on the population or not. So that is why whenever we use the variability measure for the statistical analysis, we go for the standard error. And standard error is what? Standard error is that if we will be taking number of samples from the population, that how the sample means are deviating from the population mean. So standard error is average deviation of the sample mean from the population mean, and in many tests you will see that we use the standard error. But now you might be having a question in your mind that how can we calculate the standard error, because we don't have the population mean. So there is a way to calculate the standard error from the deviation, from the standard deviation, with the formula of the standard error, that is standard deviation divided by square root n gives you the value of the standard error, and then that standard error mostly we use while we do the statistical analysis, or while we use the test of significance. Now, as just now I told you that this is the population versus sample. So this is the target population where all the subjects of the entire set of the people of the population are there. But it is not possible for a researcher to conduct the research study on the full population. So that is why out of the population we take a subset and that is known as the sample on which we conduct the study. But then based upon the findings of the sample, we try to generalize our finding on whole of the target population. I hope you understood that why do we go for the statistical analysis, because whatever findings we get on the sample, whether we can generalize those findings on the population or not, that is possible through the statistical analysis only, particularly inferential statistics where we use the different tests of the significance. Now let us talk about the hypothesis testing. So hypothesis, whatever we make, like earlier we told that it is a prediction of the outcome. So whatever hypothesis is there, that is made particularly from the point of view of the population. So statistical hypothesis is a statement about the parameter, that is the forms of the population. So when I talked to you about in the last lecture about parameter and statistics, I told you that parameter word always be used for population and statistics we use for sample. So whatever hypothesis we make, always the prediction is for the population. So statistical hypothesis is a statement about the parameter, that is forms of the population. Mostly the statistical hypothesis, we may say that the value from one sample will be is equal to the second sample, or there will not be any difference, or we may say that population parameter 1 will be also equal to the parameter 2. And null hypothesis is that there is no difference between two outcome variables. So whatever outcome variable is there, maybe it might be the knowledge score. So you may say that knowledge score of one particular sample of a community or one particular sample of the students will not be differing from the other sample. So it means it can be that the knowledge score or x1 is equal to the x2, that is knowledge score of the another sample. Or you can say if you are having the same sample and you are having two values like pre-test and post-test, so it means pre-test knowledge score will be equal to the knowledge score of the post-test. So that is the null hypothesis. So null hypothesis always tells that there is no difference between two outcome variables. Whereas alternative hypothesis, it is also known as a research hypothesis, and always alternative hypothesis we make based upon the previous findings, where we say that there is difference between the two variables under study. So where we may say that one particular sample's scores will be significantly differing from the other sample. Right. So that is the alternative hypothesis, and you need to remember that null hypothesis is always based upon the prediction that there will be no difference between the two outcome variables. And hypotheses are always about parameters of population, never about statistic from the sample. So that should be very clear that whenever we make a hypothesis, this is always made about the parameters of population. And based upon the statistical tests, in the end, if we find that there is no difference between the outcome variables, then we can accept our null hypothesis and we will reject our alternative hypothesis. But if based upon the statistical analysis after the test, if we find that there is difference between two variables, then we will reject our null hypothesis and accept the alternative hypothesis. Now, before moving forward in the hypothesis testing or tests of significance, you should be knowing what are the zones of acceptance and rejection. So just now I was telling you about acceptance or rejection of your null hypothesis. So zone of acceptance is that if the results of sample fall in the plane area that is within the mean plus minus 1.96 standard error, the null hypothesis is accepted and that area is known as zone of acceptance. So in the last lecture I talked about the normal distribution curve. So in the normal distribution curve I talked about the standard deviation, that at plus 1 and minus 1 standard deviation around 68% of the values lie, and at 2 standard deviation there are around 95% of the values which lie. So it means whenever we are saying zone of acceptance, it is, you can say it is 1.96 is equal to 2 only. So here we are talking about standard error, that you should be understanding. But why we are talking about standard error? Because here we are talking about the population parameters. So if you will be seeing this particular normal deviation curve, so in the normal deviation normal distribution curve, you can see that this is the normal distribution curve, which is the bell shaped curve, and in the center is the mu is always used for the population mean, it is not used for the sample mean. So this is the population mean, and the sample means are deviating from the mean like this. So at 1 standard deviation around 68% of the sample means will be lying, and at 2 standard deviation, or you can say 1.96 standard deviation, around 95% of the values lie. So it means 95% of the values, they lie within the acceptance range, or you can say acceptance zone. So if the values of the sample are lying within this accepted zone, then we will say that we will be accepting our null hypothesis. It means there is no difference in the sample mean and population mean, and we will be calling it as this area as the zone of acceptance. Now what is the zone of rejection? So if the result of the sample fall outside the plane area or beyond the mean plus minus 1.96 standard error, it is significantly different from the population value. So if any value is falling behind or beyond the 1.96 standard error, it means this is beyond the 95% of sample means or 95% of the values. So it means those are the extreme values, and which is not possible by chance. These are the really extreme values. So in that case, that particular zone is known as rejection zone, and here the null hypothesis is rejected and alternative hypothesis is accepted. It means that those particular values are significantly different from the population mean. So this area is called as the zone of rejection. So zone of rejection means here we reject the null hypothesis and we accept the alternative hypothesis. So if you see this particular normal distribution curve, so you can see that these areas which are really extreme, or which are beyond the 2 standard deviation, are the values which are usually 2.5 and 2.5 on either side. So it means 5% of the values are usually coming in the zone of rejection. So this particular zone where 95% of the values fall is plus minus 1.96 or plus minus 2 standard deviation. So if any sample mean is falling at this particular area, that is known as zone of acceptance. But if any value is falling beyond the 95% of values, or you can say plus minus 1.96 standard error, then those will be falling in the zone of rejection. So any values, if these are falling in this particular area, this is known as zone of acceptance. It means here we will be accepting the null hypothesis, and any value which is falling beyond this is the zone of rejection. And here if values are falling here, then we will be saying it as that our null hypothesis is rejected and alternative hypothesis is accepted. So always we set a criteria. So why I'm saying that 5% of the values, so it means we always set our criteria, we always set our level of significance, that how much level of significance we want. So mostly you might have seen that we always set the level of significance at 0.05. So what does it mean? If we are saying level of significance at 0.05, it means we are setting our level of significance at 5% and our confidence level is 95%. So out of 100, 95% is the confidence level which falls in the zone of acceptance, and 5% is the level of significance. And mostly we keep it as 5%. If we decrease our level of significance to 1%, then it means we are increasing our confidence level to 99%. So mostly there are chances that we may falsely reject our null hypothesis, or we may falsely accept our null hypothesis. So there particularly we may have difficulty if particularly sample size is small. So that is why it is better to keep the level of significance at 5%. But if you are taking really a bigger sample, then you can go for more confidence level, and level of significance can be decreased to 1%. So based upon your study, you can set a criteria for your level of significance, that where will your zone of acceptance fall and where will your zone of rejection fall. Okay, now you should be knowing that what is the difference between parametric and non-parametric tests. So whenever we want to go for the tests of significance, depending upon what type of test you want to do or what type of your distribution is there, we go for the parametric or non-parametric test. So now what is the difference between parametric and the non-parametric tests? Parametric tests are based upon assumptions that data follows normal distribution. So if your data is following normal distribution, if you plot and you form a frequency polygon, then it should be following a bell-shaped curve. So then it means your data is following the normal distribution, then you can go for the parametric test. And it also helps in estimating the parameters of underlying normal distribution also. So different parameters of the population can be calculated through the parametric tests, and through this we get to know about the significance of difference also, so that whether there is a significant difference in different outcome variables or not. The non-parametric tests are always used when our data is not following the normal distribution. Then we go for the non-parametric sets. Then we should not go for the parametric in that case. We should always go for the non-parametric tests, and there are always alternative non-parametric tests available. And through the non-parametric test we can calculate the association also. Now just now I was talking about the level of significance, and level of significance is always denoted by the p-value. So p-value provides a significant departure or some degree of evidence against null hypothesis. So it tells us that what is the level of significance and what is the degree of evidence against the null hypothesis. So if p-value is significant, it means we will be rejecting our null hypothesis. So it provides us evidence against null hypothesis. So p-value derived from statistical tests depends upon the size and direction of the effect. So always the p-value we get from the statistical tests, and it also depends upon that what is the size of the effect. Usually size of the effect depends upon the sample size also, and plus it also tells us what is the direction of the effect. So p-value is mostly, I told you that we keep the significance level at 0.05. It means we keep it as level of significance as 5%, or it can be kept as 0.001 also, which shows that highly significant. Highly significant means we are 99% confident our results are valid, and there is only chance of 1% chance, only 1% chance that the values are because of some error. So p-value, mostly you will see that level of significance we keep it as 0.05. We set that criteria, but it can come after the statistical test. We may get to know that p-value is whether significant or highly significant, and based upon the significance of the p-value, we reject the null hypothesis. And non-significant value doesn't provide the positive evidence in favor of the hypothesis. So if the value of the p is more than 0.05, then it is considered as non-significant value, and it shows that there is no positive evidence in favor of hypothesis, particularly in favor of research or alternative hypothesis. And it also depends upon the sample size. So if p is more than alpha, and then you need to calculate the power also, that what is the power of your study, and if the power is less than 80%, the difference could be detected. Repeat the study with deficit number of the study subjects. So if your power, ideally the power should be around 80%, but if it is less than that, then usually we cannot detect the differences, and we may commit some errors while interpreting or while calculating. So then we should know that power is low, so because of that our findings are not valid. Then we should repeat the study with deficit number of the study subjects. We should increase the sample size, and then again we should conduct the study, and then we should calculate the statistical analysis, and p-value should be calculated whether it is significant or not, and then based upon that significance we may reject the null hypothesis. But if power is more than equal to 80%, the difference of group is not statistically significant. If power is good, then usually it depends upon your results that the difference between groups may not be statistically significant. So you need to see that it should be always 80% at least power. If you are increasing or decreasing, it can result in sometimes errors in your findings. Now, how do we go for the tests of the significance? There are different steps. So first of all, always you know that whenever we plan our research study, we define our research questions very clearly, and then based upon the research question we go for the null hypothesis, where it says that there is no difference between the groups. And alternative hypothesis always tell us that there is some difference between the groups. So null hypothesis is always denoted by the H0 and alternative hypothesis by H1. And select, then we, based upon that, what type of test is needed, or whether you are trying to find out the test of significance of difference, or you want to find out the relationship between some variables, or you want to find out the association between some variables. Based upon that, you select the appropriate test. After selecting the appropriate test, then you have to set the test criteria, that what will be the level of significance, what will be the level of confidence, and then you decide the acceptable level of significance. Usually we keep it as 0.05, that is 5%, and then we compare the test criteria with the theoretical value at alpha. So we go for the test criteria and we compare the test value with the table value, and if it is significant, then we accept the null hypothesis. If it is not significant, then we reject the null hypothesis and accept the alternative hypothesis, and based upon that, then we make the inference in our research questions language. So these are the different steps which we use whenever we go for the tests of the significance. Now, why the test of significance is needed? First thing is testing the sample and commenting on population. So here I told you in the starting of the lecture only that we conduct the study on the sample, but based upon the statistical analysis, we comment on the population. So always test of significance is needed, that based upon our samples results, can we generalize our findings on the population? And if we are having two different samples or group means from same or different populations, we can find out that what is the difference between these two samples. whether we can take it from the same population or it can be from the different population also. Then if we want to find out the difference in the samples, we can go for the test of significance. Then another question can be answered is the difference obtained true or by chance alone? So through the statistical analysis or through the tests of significance, we get to know that whatever differences we are finding in the sample, are these the true differences, are these the valid differences, or by chance alone? To find out this, we set our level of significance, and based upon the level of significance, we can say whether our results are true or by chance alone. So because of that, we keep our level of confidence high, usually 95% level of confidence we keep, so that we should get only 5% of the we should have the 5% chances of the error only, and rest 95% we should be confident that whatever values we are getting or whatever results through statistical analysis we are getting, those are true results. Then whether another set of examples be also different, so we can compare with the another samples also, that whether there is difference or not through the tests of the significance. So significance testing, it deals with the answers to the above question. So based upon the significance tests, where we go for different types of the tests, we can say whether there is any difference in the samples, whether the difference which we are getting is true or by chance, and whether our samples which we have taken, whether it is different from another set of the samples. So we can answer number of questions based upon the tests of the significance. Now let us talk about the test of significance of differences. These tests we use whenever we want to find out the difference between two samples or more than the two sample means. So mostly whenever we are having two particular samples and we want to find out the difference between these two groups, then we go for the t-test. And the assumptions of the t-test are that samples are randomly selected. So always whatever samples we are going to on which we are going to apply the statistical test, the samples should be randomly selected. Second thing is we should have a quantitative data. So t-test is always applied on quantitative data, that you should be very clear. It is not applied on the categorical variables. It is always applied on the quantitative data. Then variables under study follow normal distribution. So always t-test can be applied, because this is a parametric test, so it is applied on the data which follows the normal distribution. And we assume that sample variance are mostly same in both the group. And t-test is usually we use when the sample size is less than 30. Now there are different types of the t-tests. First one is one sample t-test. So through one sample t-test we go for finding out the difference between the actually observed mean and the claimed mean. So here we are having only one sample, and whatever mean we get through our research study, that is compared with some known value, or you can say claimed mean. So we want to find out that whether the mean which is observed through our research study, is it significantly differing from the claimed mean or not. So that is known as one sample t-test. Second one is unpaired t-test. So unpaired t-test, here we are having two groups or two samples, and we are having two means of these two samples, and we want to find out the difference between the means of two different groups or samples. Then we go for the unpaired t-test. Third one is paired t-test. So paired t-test is where we are having one sample only, but from the one sample we have two means. Maybe we may, for example, pre-test and post-test. So in the pre-test and post-test, there we go for the one mean which may get from the pre-test and one mean from the post-test. So from the same sample we have the two datas and two means, and we want to compare the difference between the between the pre-test and post-test mean. Then we go for the pure t-test. So you should be always remembering that one sample t-test where we are having only one sample, and we try to find out the difference between the actually observed mean and the claimed mean, and unpaired t-test where we are having two different samples, and we try to compare the means of these two different samples. Whereas paired t-test we have one sample only, but we are having two sets of data. So where we go we go for comparing the mean from these two sets of the data, whether these are significantly differing or not. Now whenever we use the t-test, the formula which we use is mean difference between two samples, or difference of the means divided by the standard error. And what is standard error? Standard error is standard error of mean difference between two samples. So this is the formula for the t-test which we use. Now let us see the unpaired t-test. Here again the prerequisites whenever you have to go for the unpaired t-test, one thing is that sample size is small, less than 30, and two separate groups of the sample drawn from two separate population groups. So you are having two separate samples, and these two groups can be control and cases also. So here we set our null hypothesis as H0, where we say that mean 1 is equal to mean 2, whereas our alternative hypothesis is that H0 is not true. It means the mean 1 will be differing from the mean 2. Then we go for the t-test, where the formula I told you, the mean difference between the two means divided by the standard error of the means of the difference of the mean. So then we will be calculating the standard error based upon the standard deviation of these two groups, and then we will be calculating the degree of freedom. And degree of freedom, because here we are having two groups, so degree of freedom is always calculated as n minus 1, but here we are having two groups, so we will have n1 minus 1 plus n2 minus 1, so your degree of freedom will be n1 plus n2 minus 2. And then based upon your calculation of the t value, you will be comparing the calculated value t value with its value in the table at the p value or level of significance 0.05, 0.01, 0.001, or based upon your degree of freedom. So once you have calculated, so you will make the inference that if calculated value is more than or equal to the theoretical value, null hypothesis is rejected. So you have to see that if your calculated value is more than or equal to the theoretical value, then null hypothesis is rejected. But if your calculated value is less than the theoretical value, then your null hypothesis is accepted. And which means that if your p value is less than 0.05 for the calculated t value, then you have to reject the null hypothesis. It means you will say that there is significance difference between the two means. So mean 1 is significantly differing from mean 2 if your p value is less than 0.05. So if at the table value at 0.01 or 0.01 or 0.001 your calculated value is significant, then you will be rejecting the null hypothesis. That should be very, very clear to you. Then after unpaired, let us talk about the paired t-test. So paired t-test, I have already told you that paired sample t-test compares two means that are from same individual object or related units. The two means can represent things like I told you that you are having one sample only, but you are having two data sets, so you have two means, right? And you want to find out the difference between these two means, then you can go for the paired t-test. So you may have the measurement taken at two different times, like I gave you one example earlier, also pre-test and post-test with an intervention administered between the two time points. Or you may have measurement taken under two different conditions. For example, completing a test under a control condition and an experimental condition. For example, you might have heard about the crossover design, where the same sample may be a control condition or you may be giving them the alternate therapies. Or you may have measurement taken from two halves or sides of the subject or experiment. So you may have the measuring hearing loss in a subject's left and right ear. So same subjects are there, but you have data from the same subjects. Like you may have the hearing loss measurement from their left ear and right ear. So the purpose of test is to determine whether there is statistical evidence that the mean difference between paired observation on a particular outcome is significantly different from zero, or you can say that these are significantly differing from each other. And the paired sample t-test is a parametric test, because here again the requisite for particular this paired t-test is that your data should be normally distributed. Now data requirement, one thing is that dependent variable that is continuous. So always your dependent variable which you are calculating for the t-test should be interval or ratio level, means it should be a quantitative data, and related sample or group. So always the sample or group should be same, and the subjects in each sample or group are the same, and this means that subjects in the first group are also in the second group. So if you are having dependent observations, just like I gave you example of crossover, so the subjects should be always from the same sample. And random sample of data from the population, and your data should be normally distributed. So always a null hypothesis is that the means of the paired population are equal. So mu1 is equal to mu2, and our alternative hypothesis is that these are not equal, or these are different from each other. So whenever we go for the t-test, the test statistics for the paired sample t-test denotes t. So this is because now here we are having one sample only, so we will have the mean one only. So mean difference minus 0. So it means here you are simply taking the mean difference on two occasions, that is your mean difference divided by the standard error of the mean difference. So how do you calculate the standard error of the mean difference? Is standard deviation of the mean difference divided by the square root n will give you the standard error of the mean difference. Here you are having only one group. So here the formula for the standard error is different than the unpaired type. So I told you that this is the significant, this is the mean difference, the sample mean of the differences, n is the sample size, and this is the standard deviation of the differences, and this is the estimated standard error of the mean. So then you will see that calculate t value, it is compared to the critical t value in the table with the degree of freedom n minus 1. Now here we are having only one group, so that is why here we will be using degree of freedom as n minus 1, and then we check it on the table at that degree of freedom, and then we see whether our t value is significant or not. So if the calculated t value is greater than the critical t value, then we reject the null hypothesis. So if our calculated t value is greater than the critical t value given in the table at the level of 0.05, 0.001 or 0.01, then we will be rejecting the null hypothesis. So it means that we will be accepting our alternative hypothesis, which means that the means are significantly different. Now tests of significance of difference, we have talked about the t-test, where we talked about one sample t-test, unpaired t-test and paired t-test. These t-test is used always when we are having only two groups, but if we are having more than two groups, then we need to find out that what is the whether the means of the different groups are differing or not. So when we have to compare more than two groups, then we go for ANOVA, which is known as analysis of variance. For ANOVA, there are certain assumptions which should be fulfilled, then only we can go for ANOVA. So dependent variable should be measured at the continuous level. So that should be that here also your dependent variable which you are assessing should be quantitative variable, which should be in the interval or ratio. And independence of observation, which means that there is no relationship between observation in each group or between the groups. So whatever observations you will be comparing, those should be totally independent of each other, and there should be no significant outliers. So extreme values should not be there, because that can result in decrease in the validity of your results. So dependent variable should be approximately normally distributed for each combination of the groups of the two independent variables. So these should be normally distributed. And there need to be homogeneity of variance. So here also usually we assume that there is homogeneity of the variance of each combination of the groups of the two independent variables. Now let us talk about the different types of the ANOVA or analysis of variance. So let us talk about one-way ANOVA first. So one-way analysis of variance is used to determine whether there are any statistical significant differences between the means of 3 or more independent or unrelated groups or not. So it means if we are having more than 2 groups, 3 or more groups, and we want to find out whether the means of these groups are significantly differing from each other or not, then we go for the one-way analysis of variance. And the one-way ANOVA compares the means between the groups you are interested in and determine whether any of those means are statistically significantly different from each other. Specifically, it tests the null hypothesis. So null hypothesis H0 will be that all the means are equal to each other. So there is no difference between these different groups. And where mu is the group mean and k is the number of groups. So k can be number of groups, can be 3, it can be 4 or 5. If however the one-way ANOVA returns a statistically significant result, we accept the alternative hypothesis. So if after calculating the ANOVA we get the statistically significant result, then we accept the null hypothesis. Then we reject the null hypothesis and we accept the alternative hypothesis, which means that there are at least 2 group means that are statistically significantly different from each other. At this point, it is important to realize that one-way ANOVA is an omnibus test statistics and cannot tell you which specific groups are significantly different from each other. So it will only tell us that the means of the groups are differing from each other, but it does not tell us that which particular group is differing. So to determine that which specific group differed from each other, you need to use the post hoc test. So post hoc test tells us that which particular group is significantly differing from the other groups. So that is used only when if you are getting the significant result in the ANOVA. But if you are getting the non-significant result, then we do not go for the post hoc test because there is no significant difference. Now what is a two-way ANOVA? Two-way ANOVA compares the mean difference between groups that have been split in 2 independent variables. So for example, we are having the 2 factors, and based upon those 2 factors we want to find out the difference in the means. And the primary purpose of the two-way ANOVA is to understand if there is an interaction between the 2 independent variables on dependent variable. For example, we try to find out that based upon the gender or based upon the educational qualification whether the means are differing or not. In that case we go for two-way ANOVA. So for example, if you could use a two-way ANOVA to understand whether there is an interaction between educational level on test anxiety among university students, where education level can be undergraduate, postgraduate and doctorate. These are the independent variables and we test the anxiety score. So the test anxiety is your dependent variable. So when you want to find out the impact of these particular demographic variables on the scores or on the dependent variable, then you go for the two-way ANOVA. So what are the steps of analysis of variance? So here also first of all you have to state the null hypothesis. So null hypothesis, I told you that according to this there is no difference between the means of the different groups, and then you state the significance value, that at what level of significance you find out the difference between the means. So mostly we keep the significance value at 0.05. Then you calculate the degree of freedom. Degree of freedom is always n minus 1. So if you are having 3 groups, you will say n1 minus 1 plus n2 minus 1 plus n3 minus 1. So that will be giving you the degree of freedom. And plus degree of freedom will also be calculated based upon the total number. Then you will be calculating the F ratio, and then you will be seeing based upon the F statistics, you will check on the table at the given degree of the freedom. So if the significance level, if your value is significant at 0.05 level of significance, then we will be rejecting the null hypothesis. But if level of significance is more than 0.05, then we will accept the null hypothesis and reject the alternative hypothesis. So it means if it is significant at 0.05 level of significance, we will say that means of the different groups are significantly differing from each other. So if it is significantly differing from each other, then we can go for the post hoc test to know that which particular group is significantly differing from the other groups. So if significant, F statistics proceed for post hoc test to assess which specific group differed from the others. So with this, our lecture of test of significance is over. So let us summarize today's lecture. So inferential statistics, in which we talked about that we make the inferences about the population based upon the data from sample. So this is done through the tests of the significant, which are the part of the inferential statistics, and they offer a framework for deciding whether the sampling error that result from the sampling fluctuation is too high to provide the reliable population estimate. So whether whatever findings we are getting from the sample is are the true findings which can be applied on the population or not. The sampling distribution of mean is a theoretical distribution of means of an infinite number of the samples drawn from a population. So if we draw a number of samples from the population, that distribution is known as the sampling distribution. And I talked to you about the sampling standard error, where we find out that how the sample means are deviating from the population, which is used in many tests of the significance. And statistical inferences consist of two major types of the approaches: estimating the parameters and testing the hypothesis. So parameter estimation is used to estimate a single parameter like a mean. So parameter estimation means population mean, which we assess through the sample mean, and then we see that whether the sample mean is near to the population mean or not, or whether there is significant difference in the outcome variables or not. And the null hypothesis states that no relationship exists between the research variables, and that any observed relationship is due to chance. So that is the null hypothesis, that there is no relationship or there is no difference. So whatever observed relationship is there or observed difference is there, that is due to chance. This is not a significant difference. And rejection of null hypothesis lends support to the research hypothesis. So research hypothesis or alternative hypothesis, where we say that there is observed difference. So it means failure to reject and indicates that observed difference may be due to the chance. So it means we fail to reject the alternative hypothesis, where we accept the alternative hypothesis that the observed differences are true, not by chance. Then if a null hypothesis is incorrectly rejected, then this is known as type 1 error. If we reject the null hypothesis through error, then it is known as type 1 error, and a type 2 error when the null hypothesis that should be rejected is accepted. And researchers control the risk of making a type 1 error by establishing the level of significance, that is the alpha level, which specifies the probability that such an error will occur, and 0.5 level means that only 5 out of 100 samples would be null hypothesis rejected when it should be accepted. It means 95% confidence and only 5% chance of error is selected, and we keep our critical value or level of significance at 0.05. And in testing the hypothesis, researchers compute the test statistics and then determine whether the statistics fall at or beyond the critical region. So when we talk about the zone of acceptance and zone of rejection, then we see whether it is in the acceptance zone or rejection zone, and then based upon that we get to know whether it is significant or not, and based upon that we accept or reject a null hypothesis. And if the value of the test statistics indicate that the null hypothesis is improbable, the result is statistically significant, that is, obtained results are not likely to result from the chance fluctuation at a specified level of probability. So it means there is a significant difference or significant relationship between the outcome variables, which is statistically significant at the level of 0.05. Then parametric tests involve the estimation of at least one parameter and use of interval or ratio level data, and here the assumption is that the variables should be normally distributed, whereas non-parametric tests are used when data are nominal or ordinal and when a normal distribution is not assumed. And two common statistical tests which are used are t-test and analysis of variance, both of which are used to test the significance of difference between the group means. So we talked about the t-test, where we talked about the unpaired t-test, paired t-test, and one sample t-test or independent sample test, and analysis of variance, one-way analysis of variance and two-way analysis of variance. And ANOVA is used when here are three or more groups, one-way ANOVA, or when there are more than one independent variable. So for example, we check the demographic effect of the demographics on the dependent variable, then we go for the two-way ANOVA. I have used these books: Pollitt and Beck, Nursing Research Principle and Methods, Pollitt and Beck, Essentials of Nursing Research, Appraising the Evidence for Nursing Practice, and Mahajan's Methods in Biostatistics for the Medical Students and Research Workers. So with this, lecture is over. Now we will be meeting in the next lecture, that is lecture 14. Thank you. Have a nice day.